If you've ever spent any time in the Midwest, you'll know that we grow a lot of corn. In the United States, we grow roughly 92 million acres of corn. And as the global human population continues to grow, we need to put more food in more mouths than ever before, which means we're planting more corn. So, with more and more corn growing among other crops, more and more photosynthesis is happening. Now, photosynthesis is something we teach our kids about at a young age. We tell them that plants take in carbon dioxide, CO2, and they create the oxygen that we breathe. Keep in mind that CO2 is a greenhouse gas that takes climate change and it makes it happen faster. So, when there's more CO2 in the atmosphere, increasing photosynthesis can decrease that increased CO2. But there's a crucial part of this process that we forget to talk about. What happens to the CO2 that plants take in? The plants take the carbon dioxide from the atmosphere and they use it to make their leaves bigger, grow taller for more sunlight, and send their roots deeper into the soil. As they grow their roots, they put more and more carbon into the soil. And after the plants are harvested for their grain, the roots stay there. As the roots decompose, the carbon dioxide that was used to grow them can catch soil particles and stay there for thousands of years. The issue is that not all roots are equal. Some roots will leave more carbon in the soil, while others don't leave nearly as much. Or some roots decompose and put weak carbon into the soil that returns quickly to the atmosphere as carbon dioxide, while others put strong carbon into the soil that will stay there for long periods of time. We generally know that modern varieties of corn roots have deep, narrow roots, while old varieties have shallow, wide roots. What we don't know is what exactly makes some roots store more carbon in the soil when they decompose. Are thick or thin roots better for leaving carbon behind? Are hard, woody roots better at decomposing carbon into soil, or are soft, flexible roots superior? We really only have a vague idea of how root traits influence the normal amount of carbon that plants can store in the soil. And right now, the soil has a lot of room to store more carbon that is in the atmosphere and that is contributing to climate change. So, if we understand how different types of roots can store more carbon in the soil, we can make decisions about which varieties of corn we can plant to not only feed the ever growing human population, but we can also choose varieties that will store more carbon dioxide in the soil to help minimize the effects of climate change.